Chapter 4. Key agglomeration economies. 1. Agglomeration economies, Introduction. Firms cluster in cities to exploit external economies of scale in production. The two types of agglomeration economies are 1. Localization economies. 2. Urbanization economies. Firms cluster in cities to exploit external economies of scale in production, which occur when the activity of one firm decreases the production costs of nearby firms. Economists distinguish between two sorts of agglomeration economies, urbanization and localization. 2. Types of agglomeration economies. Agglomeration economies generate relatively low production costs for firms that cluster. The cost advantages of clustering generate large concentrations of employment. The four types of agglomeration economies are 1. Sharing intermediate input producers. 2. Tapping a common labor pool. 3. Improving skills matching. 4. Sharing knowledge. In each of these cases, the cost of production is lower for a firm in a cluster compared to an isolated firm. 3. 1. Sharing intermediate input producers. The first type of agglomeration economy discusses how some firms cluster around producer of intermediate inputs. An intermediate input is something produced by one firm and used by a second firm as an input to the production process. Firms cluster to share the producer of an intermediate input if economies of scale. Face time. What are the implications of the two conditions? Let's discuss. Some firms locate close to one another to share a supplier of intermediate inputs. An intermediate input is something produced by one firm and used by a second firm as an input to the production process. For example, a button maker produces buttons that are used as intermediate inputs by dressmaking firms. Firms will cluster to share the producer of an intermediate input if two conditions are satisfied. 1. Economies of scale. The production of the intermediate input is subject to economies of scale that are large relative to the demand of a single firm. By sharing a single supplier, final good producers are able to exploit economies of scale and get the intermediate input at a lower average cost. 2. Face time. The design and fabrication of the intermediate input requires face-to-face interaction between the producer of the intermediate input and the producer of the final good. The intermediate input is not a standardized input that can be ordered online, but instead requires face time to ensure that the input is suited to the final product. The first condition means that final good producers share an intermediate input supplier, and the second condition means that final good producers locate close to the intermediate input supplier. Sharing an intermediate input, average cost of an intermediate input. Alt text, on a line graph, horizontal axis shows quantity of intermediate input, listing Z prime and Z double prime. Vertical axis shows cost, listing C double prime and C prime. The curve for long-run average cost falls through A, Z prime, C prime, and B, Z double prime, C double prime. This graph illustrates the average cost of an intermediate input. A line indicating the long-run average cost of the intermediate input is negatively sloped. When there are economies of scale in the production of an intermediate good, the long-run average cost curve is negatively sloped. If each final good producer demands Z prime units of the intermediate input and uses its own intermediate input supplier, the average cost of the intermediate input is C prime, point. In contrast, if several final good producers together demand Z double prime units of the intermediate good from a single supplier, the average cost is C double prime is less than C prime, point B. 5. Sharing intermediate input producers, example. Dressmakers cluster around a button maker, Vernon, 1972. FaceTime is required to design and fabricate unique button suitable for a particular dress. Dressmaking firms are small and nimble. Scale economies in button production are large relative to demand per dressmaking firm. What other examples can you think of? Let's discuss. 6. 2. Tapping a common labor pool. The second type of agglomeration economy discusses how some firms cluster to share a pool of workers to reduce the costs of transferring workers from unsuccessful firms to successful firms. Market conditions for this type of agglomeration economy are as follows. Demand per firm varies from one period to the next. Workers move from declining firms to rising firms. Total market demand is constant over time. Clusters facilitate transfer of workers for lower search and relocation cost. Workers are mobile between cities, and for a Nash equilibrium in location choice, workers must achieve the same utility level at different workplaces. 7. Tapping a common labor pool. Labor pooling generates a lower wage. For workers mobile between cities, what is required to achieve a Nash equilibrium in workplace choice? How can we use the concept of certainty equivalent to translate the expected utility of the risky isolated job into dollars? Alt text. On a line graph, horizontal axis shows income in dollars, listing 100, 121, and 144. Vertical axis shows utility in utils, listing 10, 11, and 12. The switch cost is from income equals 144 to income equals 100. The curve rises through A, 100, 10, B, 121, 11, and C, 144, 12. This graph uses the concept of expected utility to show the logic of a lower wage in a cluster. The worker's utility curve is concave, indicating diminishing marginal utility of income. In this example, the utility function is U, income, equals W1/2. There is a 50% chance of being fired from either firm. Suppose for the isolated firm, the wage is W equals $144 and switching cost is $44. The favorable outcome, keep the job, is shown by point C, with net income W minus S equals $144 and utility equals 12 utils. The unfavorable outcome, get fired and incur $44 switch cost, is shown by point A, with net income W minus S equals $100 and utility equals 10 utils. The expected utility is the average of 12 utils and 10 utils, or 11 utils. 8. 3. Improving skills matching. The third type of agglomeration economy is related to the matching of workers and jobs. Workers and firms are not always perfectly matched. Skill mismatches require expensive worker training to better match workers and jobs. Key assumptions of classic model of labor matching include variation in worker skills, economies of scale in production, firm skill requirements, training cost. The third type of agglomeration economy is related to the matching of workers and jobs. In a traditional economic model of a labor market, we assume that workers and firms are matched perfectly. Each firm hires workers who have precisely the skills the firm requires. In the real world, things are not so tidy. Workers and firms are not always perfectly matched, and skill mismatches require costly worker training to better match workers and jobs. As we'll see, a large city can improve the matching of workers and firms, decreasing training costs and labor costs. 9. Agglomeration economies, labor skills matching. Alt text. In both models, laborers are shown as triangles and firms are shown as circles along a line. In the first model, there are 4 laborers at points 0, 1/3, 2/3, and 1 of the line, and 2 firms at points 1/6 and 5/6 of the line. In the second model, there are 6 laborers at points 0, 1/5, 2/5, 3/5, 4/5, and 1 of the line, and 3 firms at points 1/10, half, and 9/10 of the line. This line graph illustrates 2 equilibria in a labor matching model, one for a small city and a second for a large city. The upper panel denotes the small city and the lower panel denotes the large city. In a small city with 4 skill types and 2 firms, the skills mismatch is 1/6. The upper panel shows that workers at skill addresses 0 and 1/3 are hired by a firm with skill requirement 1/6, so each worker has a skills gap of 1/6. If the training cost of closing a unit gap, from 0 to 1, is $30, the training cost per worker is 1/6 of $30, or $5. In the lower panel, denoting a large city with 6 skill types and 3 firms, the skills mismatch is 1/10. The workers at skill addresses 0 and 1/5 are hired by a firm with skill requirement 1/10, so each worker has a skills gap of 1/10. If the training cost of closing a unit gap is $30, the training cost per worker is 1/10 of $30, or $3. A firm that moves from the small city to the large city will cut its training cost per worker from $5 to $3. The general lesson is that an increase in the number of workers improves skills matching and decreases training cost. 10. 3. Improving skills matching. The formula below illustrates the agglomeration economies associated with improved matching of workers and firms as a city's workforce grows. In general, if the number of workers in the city is n, the average skills mismatch, m, is calculated as m equals 1/2, n minus 1. As n increases, the skills mismatch decreases, m equals 1/6 for n equals 4. And m equals 1/10 for n equals 6, decreasing training costs. 11. 4. Sharing knowledge. The fourth agglomeration economy involves the benefits of sharing knowledge and promoting innovation. The sharing of knowledge provides an incentive for firms to cluster as innovation leads to lower costs and higher profit. Knowledge spillovers could occur within an industry, localization economies, but the spillovers often cross industry boundaries, urbanization economies. What are the key ideas of Alfred Marshall's classic description of knowledge spillovers? Marshall provides the classic description of knowledge spillover. When an industry has chosen a locality for itself, it is likely to stay there for long, so great are the advantages which people following the same skilled trade get from near neighborhood to one another. The mysteries of the trade become no mysteries, but are as it were in the air, and children learn many of them unconsciously. Good work is appreciated, inventions and improvements in machinery, in processes, and the general organization of the business have their merits promptly discussed. If one man starts a new idea, it is taken up by others and combined with suggestions of their own, and thus it becomes the source of new ideas. 12. Benefits of urban size. In addition to the 4 types of agglomeration economies that increase productivity and decrease production cost, 3 other advantages of city size generate lower wages production cost. Joint labor supply, better job opportunities for two-earner households. Learning, increase in human capital through learning through imitation. Social interactions, better matching of hobbies and social interests. 13. Equilibrium size of a cluster. Agglomeration economies generate external benefits that provide an incentive for firms to cluster. The clustering of firms increases total employment, generating agglomeration diseconomies that at least partly offset agglomeration economies. What would happen if there were an increase in the number of workers in a cluster? What would be the effects of an increase in population density? Each firm chooses the location that maximizes profit. In the Nash equilibrium, no firm has an incentive to change its location. Agglomeration economies generate external benefits that provide an incentive for firms to cluster. On the other hand, the clustering of firms increases total employment, generating agglomeration diseconomies that at least partly offset agglomeration economies. Consider the effects of an increase in the number of workers in a cluster. The additional workers can be accommodated by A. An increase in density, building up, or B. An increase in land area, building out. In both cases, an increase in the size of the workforce increases wages and production cost, at least partly offsetting the lower production cost generated by agglomeration economies. 14. Equilibrium versus efficient cluster size. Profit and cluster size. Equilibrium. Alt text, on a line graph, horizontal axis, lists 1, 2, and z**. The distance between 2 and z** is larger than the distance between 1 and 2. Vertical axis shows dollar, listing pi_1 and pi_2. The equation of the line for profit of an isolated firm is y equals pi_1. The curve for profit per firm rises from A, 1, pi_1, through B, 2, pi_2, reaches a peak, and then falls through C, z**, pi_1. The line graph shows the trade-offs associated with different cluster sizes. The horizontal axis shows the number of firms in a cluster, and the vertical axis shows profit per firm in dollars. The line traverses points A, B, and C. We start with a single firm at point A, and the region grows by one firm per time period. The first firm is isolated, a single firm in the cluster, and earns profit pi1. The second firm will either join the first firm to form a two-firm cluster or choose an isolated site. As shown by point B, profit in a two-firm cluster is higher, pi2 pi1, so clustering happens. As additional firms enter the region, they will continue to join the cluster, causing movement upward and then downward along the profit curve until we reach point C. Firms will continue to enter the cluster as long as the profit in the cluster exceeds the profit of an isolated firm, pi1. Starting from point C, an additional firm in the cluster would earn less profit than an isolated firm, so the next entering firm will start a new cluster. As firms continue to enter the regional economy, they form new clusters. For each additional cluster, we move from point A to point C. Once we reach point C, an additional cluster will develop, and the up and over movement along the profit curve will repeat for as many clusters as it takes to accommodate all the entering firms. The equilibrium cluster size exceeds the efficient size. 15. Equilibrium versus efficient cluster size. Alt text, on a line graph, horizontal axis lists 1, z superscript e, and z asterisk. Vertical axis shows dollar, listing pi_1 and pi_e. The equation of the line for profit of an isolated firm is y equals pi_1. The curve for profit per firm rises from A, 1, pi_1, to E, z superscript e, pi_e, and falls through C, z asterisk, pi_1. The equilibrium cluster size exceeds the efficient size. To illustrate, let's look at a line graph. The equilibrium is shown by point C, with a single cluster with z asterisk equals 30 firms and a total profit of 30 times pi1. In contrast, the efficient allocation is two clusters, each with z equals 15 firms, point E. In this case, the total profit is 30 times the profit of the typical firm, pi E. For example, if pi1 equals $5 and pi equals $12, the equilibrium total profit is $150, compared to $360 for the efficient outcome. 16. Evidence for agglomeration economies. Research in the last few decades provides evidence that the clustering of firms in cities increases worker productivity, promotes the development of new production facilities, and increases employment. How does clustering of firms in cities affect the productivity of workers? How does clustering of firms in cities promote the development of new production facilities? How does clustering of firms in cities increase employment? 17. Economic impacts of million-dollar plants. A study by Greenstone, Hornbeck, and Moretti, 2010, explored the effects of a large manufacturing plant on a metropolitan economy. What elements does the study focus on? How is worker productivity affected in existing manufacturing? Plants in the context of agglomeration economies? How does the location of a million-dollar plant affect wages? 18. Knowledge spillovers. As per research summarized by Carlton and Kerr, 2015, knowledge spillovers cause firms to cluster and increase the number of firms, firm births, and total employment. The studies drew the following additional conclusions. The largest knowledge spillovers occur in the most innovative industries. Knowledge spillovers are highly localized. Knowledge spillovers are more prevalent in industries with small, competitive firms. 19. Single industry clusters. When external economies and production are confined to firms in a specific industry, these localization economies can generate large clusters of firms producing the same product. In the United States, the most famous industry clusters are Carpets in Dalton, Georgia, 41% of national employment in carpets. Costume jewelry in Providence, Rhode Island, 55%. Elevators in Indianapolis, Indiana, 20%. Video production in Los Angeles, California, 44%. When external economies and production are confined to firms in a specific industry, these localization economies can generate large clusters of firms producing the same product. 20. Industry clusters, 1 of 3. The table lists some of the features of 8 industry clusters. Each row signifies a prominent cluster: software publishers, motions pictures and video, sound recording, insurance claims, investment banking and securities, shipbuilding and repairing, ophthalmic goods, and aerospace products. The 3 columns indicate the various features of the clusters such as metropolitan area, 2015 employment, and location quotient. For each cluster, the table shows the most prominent clusters as measured by industry employment, and the location quotient for the industry in the city. The location quotient is computed as the share of the city's total employment in the industry divided by the share of national employment in the industry. A large location quotient indicates a relatively large concentration of the industry in the city. For example, Seattle's location quotient for software publishers is 12.3, indicating that Seattle's software job count of 53,800 is 12.3 times the job count that would occur if the city's software employment share matched the national software employment share. Other software clusters occur in San Francisco, 20,700 jobs and a location quotient of 3.9, San Jose, Atlanta, and Madison, Wisconsin. Los Angeles hosts clusters in motion pictures, insurance claims, aerospace, and ophthalmic goods. New York hosts clusters in sound recording, motion pictures, and investment banking and securities. Although the cluster of sound producers in Nashville is smaller than the clusters in Los Angeles and New York, the Nashville cluster is a much larger fraction of the city's economy. 23. Corporate headquarters and functional specialization. Corporations locate their headquarters in cities to exploit agglomeration economies that cross industry boundaries, urbanization economies. Corporations cluster to share firms that specialize in providing information that is vital to corporate decisions. Corporations cluster in cities to share firms providing business services. 24. Corporate headquarters and functional specialization, CONT. In the last several decades, the specialization of cities has undergone a fundamental shift. Large cities have become increasingly specialized in managerial functions. Smaller cities have become more specialized in production. Why did these changes in functional specialization occur? 25. Agglomeration and the product cycle, the radio industry in New York. Agglomeration economies contribute to the development of new products. A study by Vernon, 1972, identifies the radio industry in New York as an example of an industry that benefited from agglomeration economies in its early design and development stage. What are the key takeaways from the study? Agglomeration economies contribute to the development of new products. The classic study by Vernon, 1972, identifies the radio industry in New York as an example of an industry that benefited from agglomeration economies in its early design and development stage. New York was attractive because it provided a wide variety of intermediate inputs and a large and diverse workforce. The area also provided production knowledge, embodied in a wide variety of production processes, that proved useful in developing a production process for the radio. When a product reaches its mature stage, with a settled design and established production process, producers have less to gain from diversified cities and may relocate to places with lower production costs because of lower wages or lower land rent. This explains why the radio industry eventually left the New York metropolitan area. 26. Nursery cities. Nursery cities are defined as large diverse cities that provide a nurturing environment for early product design and development. Diverse cities foster innovation, while specialized cities facilitate efficient production. Duranton and Puga, 2001, provide evidence regarding relocating firms. French firms, 7/10 relocated from diverse to specialized city. Highest frequency of relocation for innovative industries. Industries with mature products have less to gain from diversified cities and relocate to reduce production costs. 27.